All right, so we'll get started. My name is Andy Benson. I wear a couple different hats at Bytespeed. Do a bunch of post sales and a little pre-sales quoting and support. I install stuff. I do managed services. I'm the network administrator run everything internally at Bytespeed. I got a couple certifications. Juniper certified. Not that that really applies to this webinar, but I am a IntelliFlash administrator and installation engineer, and they are a SAN vendor that we partner with. Tedgile, they used to be owned by Western Digital. They're now owned by Tentry. I'm also Veeam certified for backups, and we'll kind of talk a bit about that um, in the next couple of slides as well. So we'll be talking kind of broad overview with virtualization, kind of how to build a cluster, kind of a few things, what not to do, what to do, and kind of just go from there. See if there's any questions, and after that. So why would we virtualize? It allows us to consolidate our resources and use them more efficiently, save power, less physical service. So, if you're renting at a data center, you have less rack space you need to rent. And, the added benefits of virtualizing is adding snapshots, high availability, and just kind of essentially using your resources more effectively. We at Bytespeed have about 30 servers. They are virtualized on 3 physical servers because we have that capacity to do it. We have 3 servers with a bunch of RAM in it, not the high-end processors, but decently powerful processors, and then shared storage. And that allows us to use those resources more effectively. If we had 30 servers, I'd have 3 or 4 more racks maybe, and then 90% of your time there, those servers aren't going to be used, so they'll be sucking down power and not being used. An example I like to use is a domain controller. You could have this really powerful domain controller with not necessarily the most powerful CPU, but overkill for what a domain controller does, and say it's 16 gigs of RAM and some SSDs in it. It authenticates, and if you're only doing that and maybe DHCP and DNS, it's very overpowered, and it authenticates, does name lookups, DHCP, and that doesn't require a lot of power. You probably get a low end Atom something and probably would be okay depending on your networks. So with that, we could take that one physical server, we can make it run multiple services, multiple virtual machines that are all isolated from each other, and allows us to take that CPU time that's just sitting there pretty much doing nothing and actually utilize it. It does, and since we are doing that, we're consolidating. We have less power we have to worry about. We have less cooling we have to worry about. So it does help, your green initiatives. If you're ISO certified, reducing that stuff is always part of their goal. And then obviously high availability as well. One of the negatives that can be, if you don't design it properly, is you get your multiple eggs in one basket. You have your multiple virtual machines running on one server. If that server goes down, you now have, instead of one service going down, or maybe a couple services, depending on how you design your servers, you have 5 or 6 or 7 or 10, or how many virtual machines you have running on that server go down. And you will have to figure out how to recover that from that one server. So that you can design around it, and there are technologies to prevent that. But if you don't, and you just have that one server, you get your multiple eggs in one basket. Something fails, motherboard, power distribution board on your redundant power supplies, you name it. That one server goes down, then all of your servers go down. Couple options out there. Hyper-V, VMware, kind of the big ones. Actually, VMware is probably the most popular right now. Hyper-V is probably not as popular. Citrix, Linux KVM, if you're into the open source world. They all, well, I guess I'm not 100% sure about Citrix, but Hyper-V and VMware also give you trials. You can run a full Hyper-V server. It's from Microsoft without a license. It's just called Microsoft Hyper-V server. It's all CLI. You could run your cluster off of it actually, if you're comfortable with the CLI. And then obviously KVM, open source, and you know, if you want support, you can pay for it, but you can dabble around with that for free. So kind of to visualize some of the abstraction of virtualization, the physical servers, you know, we can take them, put them all in one box, but then we get all that, you know, all those eggs in that one basket. So again, you know, something that we need to kind of work around and prevent. So how do we do that? We can get redundant servers, physical servers, and we can actually replicate the virtual machines between each servers. And that allows us to do planned downtime, planned migration of those virtual machines between the hosts, and allows us to keep, you know, obviously keep everything up running during maintenance. It's not 100% truly redundant, just because it's not automatic failover on Hyper-V and VMware. You could probably, you know, script something in Hyper-V and, you know, do something, but it's not like software-based redundant. So it's great for planned migration. You know, if you're wanting to start virtualizing, it's a great way to start virtualizing and still have some redundancy. It's just if something fails, you're going to have to go in, and you're going to have to do an unplanned failover and bring those virtual machines back up. It's not you know, redundant. It's not automatic failover. It's great for non-critical services. So if you need to save a little money there, you can do that. Small applications, VMs, you know, if you're not a huge infrastructure, you know, maybe you don't need that fully redundant network. So that's kind of where it fits. And it does that by essentially taking your virtual machine storage and it replicates it between the two hosts, and you can do that at intervals. So after that first seed, those intervals will start kicking off. I'm more familiar with Hyper-V, so I'll probably be talking about that a little bit over VMware, but the concepts are still the same. In Hyper-V, there's 5 seconds, 30 seconds, and 5 minutes, and you just choose the schedule there based on how much data you can afford to lose and your network. Generally, you know, something with a Replica, you're going to want to have at least a gigabit network. You know, you could go all out, isolate a 10 gig network. You know, it really is dependent on how much data changes in that time frame and what you're looking for. But that's basically how it works. Is it replicates the virtual machine storage between the two hosts. Kind of to visualize some of that, we would have virtualize or VM 1, 2, and 3 on host 1, 4 and 5 on host 2. Host 1 can replicate 1, 2, and 3 to host 2. And so if host 1 fails, you can go to host 2 and bring it up. And then host 2 would replicate to host 1. So VM 4 and 5 would be stored on host 1 as well. So if host 2 fails, you can bring them up on host 1. And the neat thing with kind of virtualization and everything is since everybody's working from home, I don't have physical servers to actually demo this on. So I actually created all of this in a virtual machine in a Hyper-V environment. So I can kind of demo that for you. So we got our two replica servers, Replica 1, Replica 2. Replica 1 is running VM 1. If we go to Replica 2, that's running VM 2. And I think we saw it kind of flash by here, but it's set to every 5 seconds. It will replicate 2-way. Now you could replicate 1-way. You could run or host running all of your virtual machines, and then the other host is just kind of standby. But that kind of goes back to that, single egg or multiple eggs, single basket issue. So if you are going to do this, my recommendation is do two-way replication. Have some of your VMs running on one host, some are running on the other. But you set up replication, and you get options to at least in Hyper-V. Here we can view our replication, and this is a touch slow since it's nested virtualization. Ooh, it looks like we got some errors. That was a couple days ago. Anyway, so you can view your replication. You can set it up pretty easily, and then you can actually, at the destination source, do your failover here. So just kind of as example, if I take and just take Replica 2 here, completely shut it off. VM1 still running because it's on Replica 1. VM2 here, no matter how long we wait, it's not going to turn on. So I'm going to have to go into our Replica here and fail over. In Hyper-V, I have an option to choose which recovery point. I just set to the latest one. Then I do my failover here. It will go through, try to make sure that everything is done correctly, and pretty much we're doing an unplanned failover here because we want to make sure that we're not going to mess up replication. But as you can see, it's not an automated process. Let me get this. Oops, that's my ugly desktop. All right, so kind of back to our slide deck here. So how do we kind of go to the next step? So if VM Replica was the entry-level redundancy, what's the next step? So the next step would be to get a cluster. That would allow you live migration between your hosts, add some dynamic resource management. So if one host was overloaded by running out of RAM, running out of CPU cycles, it will live migrate your virtual machines to the other one, kind of try to load balance your resources. Services will stay up during unplanned downtimes. So going back to the Replica demo there, I shut off Replica 2. VM2 did not come back up. If we have a physical host failure on our cluster, after a certain timeout, the other, depending on the failures, the other hosts will boot up the virtual machines on themselves and bring you back up and running, and it's all automatic. Kind of downside of that is cost. It does add additional hardware. We get some sort of SAN or licensing, vSAN. You can do stuff like that. That's more kind of hyperconverged, but it usually adds additional costs because we'll have a SAN. We'll then have some sort of SAN fabric. But the plus side of that is that you get all those the extra redundancy. You can live migrate your VMs for maintenance. If you get unplanned downtime, it will automatically boot those up. It's a pretty good fit for pretty much anything. Depending on the software, sometimes you can, the software might have its own failover and load balancing, but if it doesn't, you can put it in a VM and have the cluster manage that for you. Kind of two examples here. NextSAN is a good one. You can get a lot of storage for a good price, but it doesn't like RMA itself. It doesn't have advanced monitoring, kind of like Tintry or Nimble. They have active monitoring. They're really high performance, and then the device will literally RMA itself. I've had hard drive failures at byte speed on my SAN. I get a little notification, and boom, a drive is on my desk the next day. So the the Nimble, the IntelliFlash type SANs, they do cost more, but they do actively monitor themselves. They can be more performant depending on how you configure things. So they're pretty cool. Obviously, these aren't the only two. There's plenty out there. One thing that I would caution against is you could build a cluster on a NAS, and some NASs give you redundant controllers and stuff like that. I would recommend looking to build a cluster on a SAN, because they're designed exactly for block storage for your cluster. They're redundant. They are everything on it is redundant. Redundant network connections, redundant controllers, redundant power supplies, redundant hard drives. I would caution against NAS, unless you could use it as a test bed. But if you're building a production, I would definitely recommend doing a cluster. So to kind of visualize a little bit of that, is we have our clients that connects to our host servers, which are running our virtual machines. So technically they would connect to the virtual machines. And those host servers have a physical network. A physical usually is dedicated, a separate network to your SAN. So it's kind of confusing, but both a SAN fabric and a SAN are usually called a SAN, even though it's short for storage area network. But yeah, so your host will connect to your SAN. Popular ones are just your standard Ethernet, and the iSCSI. That one's a little less expensive than Fiber Channel. Fiber Channel is a popular one too, but Fiber Channel you can get faster, although Ethernet is starting to catch up onto Fiber Channel. Both protocols are good. Both protocols allow failover. Ethernet is just a little easier to implement because most people have some sort of Ethernet. A dedicated SAN network would be my recommendation. There is, you can technically plug them into your core network, but if you were going to do that, you will definitely want to VLAN your SAN network off, isolate it, and QoS it. So if your network starts getting overloaded, your SAN traffic continues to happen or to flow. Basically, what happens if you lose access to your data, your virtual machines will pause. And obviously, if you're running your network or your SAN network on your core network, if things start slowing down, you're going to get a lot of complaints from your end users, because it'll just compound itself. I'm actually going to skip 2 slides here because I put them out of order. So how do we kind of design a network on that? First off, we're going to try to design it to be entirely redundant. So if we have a controller failure, a power supply failure, a network cable failure, a NIC card failure, host failure, it's still going to run. Depending on the failure, we might have some downtime, but within minutes, or however you adjust those timers, they come back up. Let me see if I can get a tool here. Okay, so at the top here we have our SAN. Each of those have or the SAN has a controller in it, and they're essentially servers inside of one unit. The controllers will have multiple management ports usually, so we typically want to connect our multiple management ports up into our core network because they will have dedicated management ports on it, or an IP, I should say, for each controller. They'll have typically on the higher end SANs, you'll have a IP KVM in there, so we can KVM directly into the controller if something fails. And then they will have a floating IP that floats between the controllers where you typically manage it 99% of the time. And that will fail over between the controllers if a controller fails, or if you're doing like a firmware update, a firmware update will update the standby controller, reboot, fail over to the standby controller, and do the update on the previous active controller. So we want to have all of that connected, because if something does fail over, you will lose management. And then having that IPv KVM connected is just handy for failures. So getting to the SAN fabric, we have our 2 switches. Typically these will be isolated. Some SAN manufacturers require them to be connected. But in this example, we have them isolated. We typically, with 10 gig, you're going to enable jumble frames because you'll get a good performance boost with that. But as you can kind of see, we have each controller connected into each switch. So if we have a switch failure, our data paths are redundant and we still get there. So if you did one controller into one switch and one controller into a second switch, if you lost a switch, you lose complete access to that one controller. And you will lose, depending on your network and how it's set up, that could be quite detrimental to your performance of the array, of your cluster, and cause some downtime. So we want to have one connection minimum into each switch. Obviously, if you have more than 2 connections on each SAN or each controller, you can do multiple into each switch. But at a bare minimum, we want 2 physical paths. Same thing with the host. We got 2 connections into, or 1 into each switch, 2 connections minimum. So if we do lose something, we are able to kind of recover or automatically fail over with MPIO, etc. So to kind of like draw that out here, we still have, if we follow this one connection here, the green connection goes to switch 2, and we have a connection into our controller there. So if this connection fails, we still have the purple connection going into switch 1, which continues to go into controller 2. Sorry, controller 1. So then on our host, we could have a dedicated remote management, and in this scenario here, we did. You can load balance it and share it with your VMs if you want, depending on how much traffic you have. But we have at least one dedicated management, and preferably some sort of failover, because if you lose management to your host, obviously you can't manage it. And then minimum would be my recommendation is to have minimum 2 physical connections into your core. And the reason why I say 2 is, again, failover. If we lose connection, if we got one connection for our virtual machines and we lose it, your cluster will handle that and live migrate that host, or the VMs running on that host, to another host. But you'd be down, your virtual machines would lose network connectivity. You'd be down during that time. And if we have 2, your host will, it'll complain because we lost a connection, but we haven't lost complete failure, and so you still have network connectivity to your host. It just adds that another layer of redundancy into it. These 2 connections or multiple connections, I would recommend plugging into multiple different switches onto your core, just because that, if you have a switch failure here, it's going to cause the same problem. We'll lose connectivity to our VMs on that host. They'll have to live migrate off of that host onto another host to get that network connectivity back. Another thing to think about is that, if you have this in a data center that, or your server room, and that server room only has a single connection out to your network core, that would be the same thing. Although if that disconnects, you're probably having worse day than just losing a server on a cluster. So that is something else to think about. An example that I used, and it actually just happened recently here, is that I have I have my cluster designed and connected up exactly like this, and I lost a switch. My cluster was a little upset. It complained, but once I got because I was actually doing a firmware upgrade on my switches. Once the core of my chassis came back up on my switches, my network came back up. My cluster came back. All of the services running my cluster was back up, even though I had lost that one switch on the firmware update. And that's because I had multiple connections on the management and the virtual machine traffic from my host to my core. It was upset, but it didn't have to spend time live migrating virtual machines back and forth. So to kind of give that an example, we can go back to my test bed here. So we get rid of this replica. We have our two cluster virtual machines. We have one virtual machine in it, and we have our two. We'll have our two nodes. We'll have our shared storage. Typically, with your cluster, you're going to have some sort of disk witness that counts as a vote technically, and then you'll have a minimum of one sort of storage or data store depending on if you're on VMware. But you can have multiple ones as well. You can just do one giant storage on your SAN, or you can chop it up into services, SQL, Exchange, or you could do individual virtual machines. In this instance, I am connected up into my storage by iSCSI. This is all just all software based, all virtualized. So I don't necessarily have redundant connections in my to my storage here, but this is just an example. So if you'd either have multiple sessions to your target, or you'll have multiple targets depending on your SAN. NextSAN and Nimble and in my experience, NextSAN and Nimble, they will have one target per controller, and you'll connect and you'll have multiple sessions per controller, and then they'll just show up in having multiple ones, kind of like this. In like JetStore, QSAN, those have, and Nimble, actually Nimble too. Nimble do it this way too. I'm not sure with brand new Nimbles because I haven't used a brand new Nimble recently, but our old Nimble would have a target per one. So it kind of depends on which one you're doing. But as long as you have multiple sessions or connections to your SAN, you're going to be set. And again, that just kind of replicates each connection. When you do set that up with Hyper-V, each SAN, quote unquote SAN network, so this one and then this one, need to have separate subnets. With VMware, it doesn't care. You could go same subnet on each SAN network on Hyper-V, but it will, if you have to go pay support for Microsoft, they'll probably complain and say that is not a supported scenario. They want to isolate it to make sure that they can communication happens properly across networks. Okay, so kind of back to this. So we got our storage, we got our redundant connections to our storage, we have our disk witness, we have our multiple nodes, and then we have our virtual machine. So our virtual machine here, it's brand new Windows I just installed. I can live migrate that And if you're working with VMware, it's vMotion to the second node. And hopefully this works, because you know how it always fails on demos, right? And while it's live migrating, if my system catches up, I can interact with it. Since this is all virtualized, it's a tad slow. Normally you wouldn't run into this, but you can interact with it while it's live migrating. So what happens when you live migrate it is you obviously you tell it to do the thing, or it happens automatically. The host starts to send the RAM for the virtual machine over to another host. Storage it doesn't have to do since it's shared already, so it starts sending the RAM over. And eventually it gets caught up where it just needs to send the changes or the deltas between the two. And so technically it pauses very briefly on the source host and then sends the data changes and resumes it on the destination host. And if it resumes it on the destination host, it deletes the virtual machine out of memory on the source host. If it can't resume on the destination host, then it deletes it out of the destination host's memory and resumes it on the source host, and then throws a warning. So in this instance, we didn't get a warning, so that's good. And we're running on cluster 2 or cluster node 2. During that time, our users don't notice anything. I've tried to test that out before, even on 1 gig. I had like 1 packet drop when I had like 6 pings going on. So it happens real quick. So even though it technically pauses, your users aren't going to notice it. So it does allow for live migration. And if you wanted to put a node on for maintenance, so say we have cluster 1 here, and this node, since it's Windows, we're going to do Windows updates. I can pause it, drain the roles. That means the cluster knows that you're doing something on your on that node. We can reboot it without having to affect anything else, because the cluster knows you're doing it. All the virtual machines are now running on the second node, and you can just do whatever you need. Once you're back up and running, we can go and resume it. We can fail the roles back. In VMware, you'd be putting a node into maintenance mode. Same concept. It depending on the licensing, it will automatically migrate or vMotion the virtual machines over. You perform your maintenance, do whatever you need to do, bring the node out of maintenance mode. All right. So what would happen, just as an example, if I just shut off cluster 2? So say to simulate a host failure. I have tightened the timers quite extensively. The defaults in Hyper-V are 240 seconds, I believe. So I've tightened it just as a demo. But if I just take our cluster 2 node virtual machine, shut it off, within 10 seconds here, everything should fail over to cluster 1, and it should boot that virtual machine back up. So there, it detected it's disconnected. And we're up and running on cluster node 1. So that's kind of that automatic failover that happens if you have some sort of hardware failure. Again, going back to the replica, that doesn't happen automatically. You have to go in and hand do it. If I had more NICs on this cluster, and like I was saying earlier, the virtual machine traffic NICs got disconnected, the host will handle that. They will live migrate the virtual machines over to another host that has network connectivity. Again, your VM replica, good solution, but it won't do that. It doesn't detect any of that. So that's kind of the big advantage to the cluster. Storage size on the cluster, though, if we go back to here, we start on the more not the entry levels SANs, but starting kind of around the next SAN price range and up, you start getting additional features on your storage. You can do storage snapshots, which is essentially the same thing as virtual machine snapshots. Is that it just a snapshot of the data, you can revert back to it. Coworker of mine worked at an insurance company, and they got some ransomware. He had snapshots on his storage kick off in the morning and in the evening. So he'd get data changes that happened after hours, and then data changes that happened during the day. And again, this is all on his SAN. That user got ransomware like 7 o'clock in the morning, something like that. They found out about it about 9 o'clock. They were able to take that LUN that was running the file server and revert it back to the morning snapshot, and was just done with the ransomware. Obviously, they had some work to do with the physical desktop, but at least on the server side, they were done. So that's the advantage of snapshots. And with the snapshots, you get typically you get additional storage replica, so you could replicate your SAN to SAN. That same gentleman that I was talking about, they have 2 separate locations across the country. One was Fargo-Moorhead area. The other one was down in South Carolina. He replicated the primary data center in Fargo to the backup data center in South Carolina. And that allowed him to essentially, if this primary data center failed, he had a couple of VM hosts at the secondary data center. He was able to boot the virtual machines up at the secondary data center and just allow that storage to be replicated. It's not necessarily a backup, but it can prevent some issues, and failures. And then the big thing is storage deduplication. And so what that is, again, it happens all on the SAN. That takes identical blocks, and instead of writing them to disk, it only writes one to disk. So that will reduce your physical disk usage on your SAN. Depending on the manufacturer you look at, they will tell you different compression and deduplication rates. It's really good for VDIs. If you have VDI, you're going to have a lot of identical data on those virtual desktops. That storage deduplication can or will take that identical data, put a reference pointer to it, and only store one block of data. An example I will use is we cut our data in half just because all of our virtual machines are all Microsoft Windows, because we're a Microsoft partner. It cut our data storage in half with the deduplication updating to our current SAN, because our previous one didn't have it. So that depending on your storage data or your actual data, it can be a big factor in saving space. Now, if you have a bunch of non-deduplicable files, databases, bunch of compressed media, film, pictures, stuff like that, you probably won't get near that benefit, but it will still attempt, and then you'll have your compression on top of that too. All right, so after a virtual cluster, and this is kind of more of a recent scenario, is hyperconverged. It reacts and runs same as a VM cluster, same kind of benefits, but the big benefit is that there's no dedicated hardware, so there's no SAN. There's no, not necessarily SAN network, but there's still going to be some backbone to it. But it can be run on just standard off-the-shelf servers, nothing too fancy. And then the other big benefit, and this is kind of really the reason why you would do hyperconverged, is it allows for both compute and storage to scale incredibly quickly. If you need more compute, you just start adding servers. And if you need more storage, you start adding servers. But everything is done on the server. It has your compute is on the same server that is running your storage. So you'll have your storage, some sort of RAID card or DAS connected into your server, physically attached to it. And so if you just need that to scale quickly, you can use Hyperconverged to do that. If we went back to our cluster example here, if we want our compute to scale, you start adding hosts. If you want your storage to scale, you start adding either expansion shelves to your SAN or multiple SANs. So it's a little more static. Your compute can scale incredibly quickly on a cluster with a SAN, but storage, it's not necessarily as easy. So with Hyperconverged, you scale both storage and compute at the same time, and it just allows you to do it incredibly quickly because all it does is you just throw on a new server, connect it up. You will have your backbone. Most of the time, it's going to be 10 gigabit or faster. So you will have some sort of backbone as well, but you don't have that dedicated SAN appliance. Some of the negatives on that is that it can cost the same as or as much as a standard cluster, because it can require extra licensing depending on who you go with. Obviously, if you go open source, all you have to do is pay for support typically. You don't have to pay for software, but if you go with VMware and Hyper-V, it will typically require extra licensing to do that. VMware is vSAN, and then I think Dell has a VxRails. I think Dell is a hyper-converged vendor for them. Hyper-V is literally Hyper-V server with storage spaces direct. Storage spaces direct requires data center. So they both typically require extra licensing. It can be a little more complex depending on how you think. Everything is kind of more abstract on your hyper-converged because everything is done in software. Now, there are experts at this. There are software or hyper-converged solutions that just basically do everything yourself. But if you are doing more of the solutions that allow you to customize some of that, it can be a little harder to kind of visualize those abstract concepts. But it gets you kind of end goal as a cluster with the additional benefit of scaling very quickly. It will fit kind of really anything that you're doing. Same thing that will run on a cluster, or a cluster with a SAN will run on hyper-converged. And it's the best option if your services require things to scale quickly. So like if you're thinking about these new online video games that come out, typically they're quite popular after they come out, and they drop popularity. So if we're running something like that, you could take your hyperconverged infrastructure, and then if you don't predict the scale of your requirements properly, you can quickly expand to those requirements by just start adding in physical servers. Okay, so I don't really have a slide or anything else besides hyperconverged. I just wanted to touch on that. The last thing I did want to touch on is kind of your backups again. Your eggs on both hyperconverged VM replica and a cluster with a SAN. You still have the possibility of a complete failure, and you want to back that up. There are solutions out there that allow you to kind of recover quickly depending on the scenario. I'm gonna use Veeam as an example, but their Barracuda Backup also has this feature, so it's not just exclusive to Veeam. But in Veeam's, and I think Barracuda, they call it instant VM recovery or something along that lines, because what it allows it to do is it boots a VM up on your compute, on your cluster or some sort of testbed somewhere where you have compute resources, and it proxies the storage back to the backup server. So your VM is literally booting up on the backup storage on your backup server or backup appliance. And that allows it to boot up pretty quickly. I've used this a couple times at byte speed. I've messed something up. I've used VM to restore it with the instant VM recovery. VM is back up in less than a minute. It doesn't run as fast because typically, and this is how our backup system is designed as well, typically your backup solution is designed for bulk storage instead of speed. So it doesn't run as fast as if it was on your SAN, and then depending on your network, it's got to proxy it back. So our network, we have 2 gigabits of throughput to our backup server, which is 5 times less than our 10 gig. So even if I did have that performance on my backup server, it's still limited by the network, but it allows me to boot it up and get back up and running really quickly. And then depending on how busy production is, you can start migrating that storage back to your production while it's running. So it kind of live migrates or vMotions the storage off of your backup server, your backup appliance, onto your production storage, so your virtual machine can continue running. So that's a cool feature with your virtual machines and your backups, but always want to back it up because something could happen. It's not an if, it's just a when. Something's going to happen, and you could have a complete catastrophic failure of your cluster as well. And so you always want to have some sort of backups. And with that, that's the end. So if there's any questions, I will feel free to shoot them through chat. Otherwise, in a minute or two, we'll probably just end the webinar. All right, I think we'll just call it a day. And if you got any questions, feel free to reach out. I believe the email's got the invite has got my email on it. If not, you can find me on our website as well. Got lots of experience deploying those. So if you need any help, we're definitely available. Thanks.